66 million years ago, the sun rose over a landscape that no longer exists. Across what would one day become the American West, vast floodplains stretched beneath warm, humid skies. Rivers carved through forests of flowering plants and ancient conifers. And moving through this world, feeding on the low vegetation along the forest edge, was a creature unlike anything alive today. Triceratops. A name most of us learned in childhood, often alongside Tyrannosaurus Rex and Stegosaurus. But while these animals populate our museums and capture our imaginations, there's something unique about Triceratops that sets it apart in the story of prehistoric life. It wasn't just another dinosaur. It was one of the last. When paleontologists examine the rock layers that mark the final chapter of the Mesozoic era, they find Triceratops fossils in abundance, right up until the very end. This massive herbivore, weighing as much as an elephant and bearing 3 prominent horns and an enormous bony frill, thrived in an ecosystem that was already changing. While other species came and went, Triceratops endured. It adapted. It succeeded where others failed. And then, in what scientists describe as a geologically instantaneous moment, it vanished completely. This presents us with a paradox. How does a creature so seemingly well adapted, so successful in its environment, disappear so absolutely? What allowed Triceratops to dominate the late Cretaceous landscape? And what forces proved too powerful for even this armored giant to withstand? The answers lie in understanding not just the animal itself, but the world it inhabited. Evidence suggests that Triceratops was far more than a walking museum piece. It was a sophisticated herbivore with specialized feeding adaptations, possibly complex social behaviors, and defensive capabilities that made it a formidable presence even to the largest predators of its time. The fossil record reveals an animal that evolved relatively late in dinosaur history, but quickly became one of the most common large animals in North America. Yet that same fossil record tells us something else. It shows us that success, even measured in millions of years and countless generations, offers no guarantee of permanence. The story of Triceratops is ultimately a story about the delicate balance between adaptation and catastrophe, between evolutionary triumph and ecological collapse. To understand what happened, we need to trace this animal's journey from its origins, through its dominance, and into its final days. We need to examine the evolutionary innovations that made it possible for Triceratops to thrive, the ecosystem that supported its existence, and the forces that no amount of armor or adaptation could defend against. Along the way, we'll encounter questions that paleontologists are still working to answer, and evidence that continues to reshape our understanding of these final moments in the age of dinosaurs. This is the story of rise and fall, played out over 2 million years on a planet that was simultaneously familiar and utterly alien. It begins not with extinction, but with evolution. 68 million years ago, the landscape of Western North America looked nothing like the continent we know today. Where prairies and mountains now stand, vast floodplains stretched beneath subtropical skies, rivers carved through dense forests of conifers and flowering plants. Herds of massive creatures moved across the land in numbers that likely rivaled the great migrations of modern Africa. This was the Late Cretaceous period, the final chapter of the age of dinosaurs. These remarkable animals had ruled the world for more than 160 million years. But time was running short. In less than 2 million years, an event would unfold that would change the course of life on Earth forever. The creatures living in this ancient world had no way of knowing what was coming. They lived, as all animals do, adapting to their environment and struggling to survive. Among the most successful of these animals was a creature that has captured our imagination for decades. Standing nearly 10 feet tall at the shoulder and stretching up to 30 feet from nose to tail, Triceratops was a giant among herbivores. Its massive skull, adorned with 3 distinctive horns and a broad bony frill, made it unmistakable. Some estimates suggest this animal could weigh up to 12 tons. This is roughly equivalent to 2 modern elephants, though its build was far more powerful. Triceratops was not merely large, It was abundant. Fossil evidence suggests these horned dinosaurs were among the most common large animals of their time. Their remains are found throughout what is now Montana, Wyoming, and the Dakotas. In some fossil beds, Triceratops bones outnumber those of nearly every other dinosaur species. This suggests to many paleontologists that these populations once dominated the landscape. This abundance is remarkable when we consider the world Triceratops inhabited. The Late Cretaceous was a time of giants. The Tyrannosaurus Rex stalked these same forests and plains, acting as one of the most formidable predators ever to walk the earth. Armored ankylosaurs trudged through the undergrowth, while duck-billed hadrosaurs gathered in vast herds. Yet Triceratops did more than just survive in this dangerous world. It thrived. What made this possible? How did a plant-eating animal, moving on 4 powerful legs, defend itself and its young against predators that could crush bone with a single bite? What adaptations allowed Triceratops to become so numerous while other herbivores remained relatively rare? Perhaps most intriguingly, what can this animal tell us about the final days of the dinosaur age? These questions have driven paleontologists for more than a century, ever since the first Triceratops fossils were unearthed in the American West. Each new discovery has added another piece to the puzzle. These finds reveal more than just the anatomy of the creature. They offer glimpses into how it lived, how it behaved, and how it fit into an ecosystem that would soon vanish from the Earth. To understand Triceratops is to understand resilience and adaptation. It is a study of the delicate balance between survival and extinction. This is the story of a giant that walked in the shadows of a changing world, unaware that it was living through the final act of an age. The story of Triceratops begins not in the forests of North America, but millions of years earlier and half a world away. To understand how this massive creature came to be, we must trace a lineage that stretches back more than 90 million years. This was a time when the ancestors of horned dinosaurs looked nothing like their famous descendants. The earliest ceratopsians were small, unassuming animals. Evidence from early fossils suggests these pioneers were roughly the size of a large modern dog. They walked on 2 legs and possessed only the most modest hints of what would come. Creatures like Chicxulub, whose fossils have been found across Asia, show us the humble beginnings of this family. They had no horns and no elaborate frills. Instead, they possessed a simple, parrot-like beak that gave them their name. Evolution rarely moves in straight lines. Over tens of millions of years, the ceratopsian family tree branched and diversified. Some lineages developed small frills at the back of their skulls. Others grew larger, and their bodies became too heavy for 2 legs alone. The shift to walking on all 4s opened new possibilities. This allowed these animals to grow to sizes that would have been impossible for their bipedal ancestors. By the Late Cretaceous, ceratopsians had become some of the most spectacular animals on Earth. The transformation was remarkable. What began as small defensive structures had evolved into elaborate displays of bone and horn. The simple beak had been refined into a powerful shearing tool, capable of processing the toughest vegetation. Evidence suggests that somewhere along this evolutionary journey, these creatures made their way across ancient land bridges from Asia to North America. It was in North America that the ceratopsian story reached its culmination. Around 68 million years ago, a new species emerged in what is now the western United States and Canada. This was Triceratops. It represented one of the largest and most specialized lineages of horned dinosaurs to ever exist. The name means 3-horned face, and the description is fitting. 2 massive brow horns, each capable of growing more than 3 feet long, projected forward above the eyes. A shorter nasal horn rose from the snout. Behind these weapons sat a solid shield of bone. This frill could span more than 7 feet across in the largest individuals. Unlike some of its relatives whose frills were pierced with large openings, the frill of a Triceratops was mostly solid. This leads many researchers to propose it provided robust protection, though its role in display remains a subject of study. The skull alone could measure up to 8 feet in length. It stands as one of the largest skulls of any land animal that has ever lived. The body that supported this massive head was built like a fortress. 4 sturdy legs, each ending in broad, weight-bearing feet, supported a barrel-shaped torso. From the tip of its beak to the end of its relatively short tail, an adult Triceratops could reach 30 feet in length. It stood roughly as tall at the shoulder as a modern African elephant. Our knowledge of these creatures comes primarily from 2 geological formations. The Hell Creek Formation, stretching across Montana, North Dakota, South Dakota, and Wyoming, has yielded numerous Triceratops specimens. The Lance Formation of Wyoming has proven equally rich in fossils. In these ancient rock layers, paleontologists have found more than just scattered bones. They have discovered nearly complete skeletons, allowing us to reconstruct this animal in remarkable detail. What emerges from this fossil record is a picture of an animal perfectly adapted to its world. It was the result of millions of years of evolutionary refinement. But adaptation alone does not explain dominance. To understand why Triceratops became so successful, we must look beyond its anatomy to how it actually lived. To understand how Triceratops thrived in one of the most dangerous environments in Earth's history, we must examine the remarkable machinery of survival provided by evolution. Every feature of this animal tells a story of adaptation. From its imposing skull to its powerful limbs, it was built for a world where only the well-equipped could endure. The skull of Triceratops remains one of the most debated structures in paleontology. Those 3 horns and the massive frill behind them have prompted decades of scientific discussion. Evidence suggests they served multiple purposes. Researchers continue to explore which of these functions was most critical to the animal's life. While defense is a prominent theory, scientists also weigh its importance against social functions. Triceratops shared its world with Tyrannosaurus Rex. This was a predator with a bite force that exceeded any known land animal. Some Triceratops fossils bear marks that match the teeth of these giant predators. These are signs of violent encounters that the horned dinosaur survived. The brow horns and the solid frill protected the vulnerable neck. This suggests a formidable defensive strategy. However, modern studies indicate that direct ramming might have risked damaging the skull itself. Many paleontologists believe display played an equally important role. Like the antlers of modern deer, these structures may have been used in contests between individuals. They likely served as tools for competition over mates or territory. Some specimens show healed injuries to their frills and faces. These wounds are consistent with combat from the front, rather than attacks from a predator. The frill was highly visible and unique to each individual. It may have served for species recognition or as a way to intimidate rivals. Behind that impressive skull lay another adaptation crucial to survival. This was an extraordinarily specialized feeding system. The jaws of Triceratops housed dental batteries. These were rows of tightly packed teeth that formed a continuous shearing surface. As teeth wore down, new ones grew in to replace them. This created a conveyor belt of cutting edges that never dulled. It allowed Triceratops to process the tough, fibrous vegetation of the Late Cretaceous. They could eat palms, ferns, and the woody plants that other herbivores might struggle to digest. The body that supported this feeding machine was engineered for strength. 4 columnar legs bore the tremendous weight of the animal. These bones were far thicker than those of other animals of a similar size. The front limbs were built primarily for support. This was not an animal designed to run from danger. Instead, it was built to stand its ground. Analysis of bone biology has revealed intriguing patterns in how these animals grew. Juvenile Triceratops appear to have experienced rapid growth in their early years. Their bones show dense growth rings. This suggests they reached adult size relatively quickly. Such fast maturation was likely a key survival strategy. It reduced the time young animals spent in a vulnerable, smaller state. While Triceratops fossils are often found alone, some rare discoveries suggest a more social nature. Bone beds containing multiple individuals hint that they may have gathered in groups at certain times. Whether they lived in permanent herds or came together seasonally is still a mystery. However, These finds point to social behaviors we are only beginning to understand. What becomes clear is that Triceratops was an animal equipped for a challenging existence. It carried the tools it needed not just to survive, but to dominate its ecosystem. 68 million years ago, the Hell Creek ecosystem was a world of contrasts. Where arid badlands now stretch across Montana and the Dakotas, broad floodplains wound between forested highlands, rivers carved meandering paths across the landscape. Their courses shifted with seasonal floods. The climate was warm and humid, far warmer than the region is today. Evidence suggests the land experienced distinct wet and dry seasons that shaped the rhythms of life. This was a world in transition. The plant life that sustained Triceratops looked fundamentally different from the forests of earlier periods. Flowering plants, known as angiosperms, were rapidly diversifying. Their evolutionary innovations allowed them to outcompete many traditional plant groups. Alongside these newcomers, ancient conifers still stood tall. Ferns carpeted the forest floor and crowded the riverbanks. Palms swayed in the subtropical breeze, creating an ecosystem rich in variety and resources. For Triceratops, this botanical abundance meant opportunity. Evidence from tooth wear patterns suggests these animals were low-browsing herbivores. They fed on vegetation within a few feet of the ground. Their powerful beaks could crop tough stems and fronds. Their dental batteries processed fibrous material that would challenge many other herbivores. Researchers have analyzed fossilized dung, known as coprolites. These samples contain fragments of woody plants and ferns, giving us glimpses into an ancient diet. Triceratops did not roam this landscape alone. The Hell Creek ecosystem supported a remarkable diversity of herbivorous dinosaurs. Duck-billed hadrosaurs, like Edmontosaurus, gathered in groups along waterways. Their elaborate nasal passages suggest complex vocalizations that may have echoed across the floodplains. Armored ankylosaurs lived as fortresses covered in bony plates. They browsed the undergrowth while wielding clubbed tails for defense. Other horned dinosaurs, such as the smaller Leptoceratops, occupied different ecological niches. This suggests that these species shared the available resources. But the defining relationship in this ecosystem was one of predator and prey. Tyrannosaurus Rex, the apex predator of Hell Creek, left its mark on Triceratops in ways that paleontologists can still read today. Several Triceratops fossils bear bite marks consistent with the size and spacing of Tyrannosaurus teeth. Some of these wounds show signs of healing. This is evidence that Triceratops could survive encounters with the most formidable predator of its time. Other specimens suggest less fortunate outcomes. The nature of these interactions remains a subject of scientific debate. Did Tyrannosaurus actively hunt healthy adult Triceratops? Or did it primarily target the young, the sick, and the dying? Some researchers argue that a full-grown Triceratops was a dangerous opponent even for an adult Tyrannosaurus. Others point to evidence suggesting that these predators did take down healthy prey when the opportunity allowed. The truth likely varied with the circumstances. The age and health of both animals determined the outcome of each encounter. One of the most intriguing questions concerns how these animals lived day to day. Did they move in herds like modern bison? Or were they more solitary, like modern rhinoceroses? The fossil evidence remains ambiguous. Unlike some of their relatives, Triceratops specimens are more commonly found as isolated individuals. Yet rare bone beds with multiple animals suggest occasional grouping behavior. Scientists continue to debate whether these gatherings represent true social groups or simply coincidental deaths at the same location. What is clear is that Triceratops had found a way to thrive. They navigated a complex web of competition, predation, and seasonal change. For nearly 2 million years, these giants endured. They adapted to their world with remarkable success. But that world was about to change in ways no adaptation could overcome. In the final 2 million years of the Cretaceous period, Triceratops achieved something remarkable. While some researchers suggest certain dinosaur lineages were declining, the fossil record shows that Triceratops continued to flourish. The evidence of their success is written in stone across western North America. Paleontologists working in the Hell Creek and Lance formations consistently find Triceratops remains. These fossils are found in numbers that suggest the animals were among the most common large creatures of their time. In some locations, their bones account for more than half of all large dinosaur fossils recovered. This level of abundance was sustained right up until the very end of the Cretaceous. It indicates a species that had successfully adapted to its specific ecological niche. What made this success possible? The answer lies in a combination of factors. Each contributed to the ability of Triceratops to thrive where others struggled. Their feeding adaptations gave them a crucial advantage. The dental batteries that lined their jaws allowed them to process vegetation that many other herbivores could not efficiently consume. As flowering plants continued to diversify and spread, they created new types of plant communities. Triceratops adapted alongside them. Evidence from tooth wear patterns suggests these animals could handle a variety of plant materials. They ate everything from soft fronds to woody stems. This dietary flexibility meant that seasonal changes or shifts in plant life posed less of a threat to them than to more specialized feeders. The defensive capabilities of Triceratops also played a role in their success. In an ecosystem dominated by one of the largest predators ever to walk the earth, the ability to defend oneself was essential. The horns and frill that make Triceratops so recognizable were tools of survival. They acted as deterrents that made even a hungry Tyrannosaurus think twice before attacking a healthy adult. Perhaps most importantly, Triceratops had found its niche. As a low-browsing herbivore focused on plants close to the ground, it occupied a different feeding zone than the tall-browsing hadrosaurs. This specialization reduced direct competition for food. It allowed multiple large herbivore species to coexist in the same ecosystem. One question has intrigued paleontologists for decades. It concerns the relationship between Triceratops and another horned dinosaur found in the same rocks called Torosaurus. With its even larger frill pierced by distinctive openings, Torosaurus was long considered a separate species. However, some researchers have proposed that Torosaurus may simply represent elderly Triceratops individuals. This theory suggests their frills continued to grow and change shape throughout their lives. The debate continues. While some evidence suggests a growth link, many paleontologists maintain they are distinct species based on differences in bone structure and fossil distribution. What cannot be disputed is that Triceratops populations remained stable and abundant throughout the final stages of the Cretaceous. The fossil record shows these animals thriving in their environment. Their populations were seemingly secure. Other horned dinosaur lineages had come and gone, but Triceratops persisted. It was a successful adaptation to the late Cretaceous world. In many ways, Triceratops represents one of the last and most highly specialized lineages of its kind. They were one of the final great megaherbivores of the Mesozoic era. For nearly 2 million years, these giants grazed the floodplains of western North America. Their populations were healthy and widespread. They had weathered countless challenges and established themselves as dominant members of their ecosystem. But dominance is never permanent. Beyond the horizon, an event was approaching that would test every living thing on Earth. It would do so in ways that no amount of evolutionary refinement could prepare them for. 66 million years ago, the world that Triceratops inhabited was already beginning to change. The Hell Creek ecosystem, for all its abundance and diversity, existed in a time of mounting environmental pressures. Even without knowing what was coming, the planet was showing signs of stress. Halfway around the world, in what is now India, massive volcanic eruptions were transforming the landscape. The Deccan Traps, as geologists now call this volcanic province, had been erupting in pulses for hundreds of thousands of years. They poured enormous quantities of lava across the subcontinent. With each eruption came gases, such as sulfur dioxide and carbon dioxide. These were released into the atmosphere in volumes that many scientists suggest altered global climate patterns. Scientists continue to debate the full impact of this prolonged volcanism, but evidence suggests it was affecting temperatures and atmospheric chemistry across the entire planet. Sea levels, too, were in flux. The shallow seas that had covered much of the interior of North America during earlier parts of the Cretaceous were retreating. They drained away and exposed new land. This transformation reshaped coastlines and altered weather patterns. It created cascading effects throughout ecosystems that had evolved in a world of shallow, inland oceans. Climate itself appears to have become less stable. Some evidence points to temperature fluctuations and shifts between warmer and cooler periods. These shifts would have influenced plant communities and the animals that depended on them. The subtropical world of the Late Cretaceous may have been experiencing growing unpredictability. Some researchers have proposed that these environmental stresses were already taking a toll on dinosaur diversity before the final catastrophe struck. The evidence remains debated. Different fossil sites tell different stories. Some studies suggest that certain dinosaur groups were becoming less diverse in the final millions of years of the Cretaceous. Whether this represented a genuine decline or simply gaps in the fossil record remains a subject of discussion. This includes the Senior Lips effect, where rare fossils make species appear to vanish before they actually did. Yet, through all of this, Triceratops endured. Their fossils appear in the very youngest Cretaceous rocks. These were sediments deposited in what scientists believe were the final thousands of years before the end. They are found in the last meter of rock laid down in the age of dinosaurs. Current fossil evidence indicates Triceratops populations remained present and broadly distributed until the very end. But no amount of adaptation could prepare them for what was about to happen. The scientific evidence is now overwhelming. 66 million years ago, an asteroid approximately 6 miles in diameter struck the Earth in what is now the Yucatan Peninsula of Mexico. The impact created the Chicxulub crater, a scar more than 110 miles across. It is buried today beneath layers of sediment, but its geological signature is unmistakable. This is a well-established scientific explanation, supported by evidence from around the world. The energy released by this impact was almost unimaginable. Estimates suggest the kinetic energy was equivalent to billions of atomic bombs. This is orders of magnitude greater than any explosion in human history. The asteroid struck at a speed of more than 40,000 miles per hour. It vaporized itself, and enormous quantities of rock in an instant. This sent debris and superheated material cascading into the atmosphere and across the planet. For the creatures living in that moment, including the Triceratops populations grazing across North America, the world they knew was about to end. What happened next would unfold across hours, days, months, and years. It was a cascade of catastrophes that would reshape life on Earth forever. The asteroid struck in the morning, local time, slamming into shallow tropical seas off what would one day become Mexico's Yucatan Peninsula. In an instant, the impact released energy equivalent to the detonation of billions of nuclear weapons. The asteroid itself vaporized, along with thousands of cubic miles of Earth's crust. This material transformed into superheated plasma that expanded outward at incomprehensible speed. The immediate effects were catastrophic. A shockwave rippled through the planet's crust, triggering earthquakes far more powerful than any in recorded human history. Molten rock and vaporized material were hurled into the upper atmosphere. Some debris achieved enough velocity to escape Earth's gravity entirely. Other fragments rained back down as a worldwide barrage of shooting stars. Some models suggest that intense thermal radiation may have ignited forests across parts of North America, potentially leading to widespread wildfires within hours. Tsunamis radiated outward from the impact site, while seismic activity likely triggered massive water surges, known as seiches, in inland waterways. Evidence from sites in the Hell Creek Formation suggests these surges carried a chaotic mixture of debris and vegetation. They inundated floodplains and buried ecosystems under layers of sediment. But the waves and fires were only the beginning. The real killer came more slowly. Trillions of tons of pulverized rock, soot from fires, and sulfate aerosols hung, suspended in the atmosphere. This created a shroud that encircled the planet. Sunlight, which had warmed the Cretaceous world and powered its ecosystems, was blocked. Temperatures plummeted. What scientists call an impact winter had begun. It persisted for months, while environmental cooling likely lasted for a decade or more. Without sunlight, photosynthesis ground to a halt. Plants that had survived the initial catastrophes now withered and died in the cold and darkness. When the plants died, the food chains began to collapse from the bottom up. Small herbivores starved first, followed by the predators that fed on them. Then the larger herbivores, those with the greatest food requirements, found themselves in a world where their sustenance had simply vanished. For Triceratops, survival was impossible. An animal weighing up to 12 tons needed enormous quantities of plant material every day just to maintain itself. Their specialized feeding adaptations, so successful in the Cretaceous world, now worked against them. The low-growing plants they had evolved to process were gone, buried under ash or dead from lack of light. Even if some vegetation survived in isolated pockets, it would not have been enough to sustain populations of such massive animals. Their biology offered no escape. Triceratops likely had long generation times. They took years to reach maturity. It is often hypothesized that females produced relatively few offspring compared to smaller, faster breeding animals. In a rapidly collapsing ecosystem, there was no time to adapt. There was no opportunity for populations to shift their diets or evolve new strategies. The world was changing faster than evolution could respond. The fossil record captures this moment with stark clarity. At the KPG boundary, a thin layer of clay enriched with iridium from the asteroid Triceratops, fossils simply stop. Below this line, they are abundant. Above it, they are absent. The disappearance is abrupt and geologically instantaneous. It is a boundary between presence and oblivion. Yet, extinction was selective. Small animals, those that could burrow or hibernate, and those with modest food requirements, had a chance. Mammals, most of them no larger than modern rats, survived in underground refuges. Some birds, descendants of earlier dinosaurs, made it through. Crocodilians and turtles, capable of slowing their metabolisms and enduring long periods without food, persisted. But the great land animals, the giants that had dominated for millions of years, could not. Triceratops was among the very last of the non-avian dinosaurs to walk the earth. For 160 million years, dinosaurs had ruled the land. Now, in what must have seemed like an endless night, that age came to an end. The horned giants that had thrived just days before were gone. Their era was closed, and their world was transformed into something unrecognizable. 66 million years after the last Triceratops walked the earth, we continue to study their remains, piecing together the story of their existence from fragments preserved in stone. In many ways, Triceratops has become one of the most studied dinosaurs in paleontology. Their abundance in the fossil record providing scientists with unprecedented opportunities to understand not just a single species, but the nature of life itself during the final chapter of the Mesozoic era. What emerges from this study is a portrait of both resilience and vulnerability. Triceratops thrived for nearly 2 million years in a challenging world, adapting to environmental pressures, coexisting with formidable predators, and maintaining stable populations even as other lineages struggled. Yet all of that success, all of that evolutionary refinement, could not protect them from a catastrophe that struck too suddenly and too completely for adaptation to occur. The story of Triceratops offers profound lessons about mass extinction events. When ecosystems collapse, size and specialization become liabilities rather than advantages. The very traits that made Triceratops successful, their large bodies, their specialized diets, their particular ecological niche, became insurmountable obstacles when the world changed in an instant. Evidence suggests that survival in such events favors generalists, small body size, and the ability to enter dormant states or exploit refugia that larger animals cannot access. These patterns resonate in our modern world. Today, scientists document declining biodiversity at rates that some compare to previous mass extinctions, though the causes and timescales differ dramatically from the asteroid impact that ended the Cretaceous. Large-bodied specialists, animals with specific habitat requirements and slow reproductive rates, face disproportionate risks from habitat loss and environmental change. The mechanisms differ, but the underlying principles of vulnerability remain remarkably consistent across geological time. Yet, there is an important distinction. The Chicxulub impact was instantaneous and unavoidable, a catastrophe beyond any organism's capacity to influence or escape. Modern environmental changes, while significant, unfold over longer timescales and arise from causes that human societies can, at least in principle, address. The fossil record teaches us about vulnerability, but it does not dictate inevitability. The fascination with Triceratops extends beyond scientific circles. Few dinosaurs capture the popular imagination quite like this three-horned giant. Perhaps it is the dramatic appearance, the combination of horns and frill that seems designed for ancient combat. Perhaps it is the abundance of fossils, which makes Triceratops feel more real, more knowable than rarer species. Or perhaps it is the poignant timing. Triceratops represents the end of an era, the last of the great horned dinosaurs, present until the very moment when everything changed. Many questions about Triceratops remain unanswered. Despite decades of study, we still debate the details of their social behavior. Did they gather in groups, or were they primarily solitary? The fossil evidence offers tantalizing hints, but no definitive answers. We continue to discover variation among specimens, raising questions about whether we are seeing different species, different sexes, or simply different stages of growth. And the exact circumstances of their final days, how quickly populations collapsed, whether some individuals survived longer than others, remain subjects of ongoing research. What we can say with certainty is that dominance is never permanent. Triceratops ruled the late Cretaceous landscape, one of the most successful large herbivores in their world. They had survived for millions of years, weathered environmental challenges, and established themselves as fundamental components of their ecosystem. Yet in geological terms, an instant, really, they were gone. This is perhaps the most profound lesson their fossils teach us, that Earth's history is one of constant change, of rises and falls, of dominance and extinction. The planet endures, life persists, but individual species, no matter how successful, exist only for a time. Triceratops had their moment, millions of years in duration, an empire of horn and bone. And then the world moved on, as it always does, writing new chapters over the remnants of the old.